We are working through question 7, so let's begin by giving it a read. It says the graph of the relation y equals the square root of 1 minus x squared is shown on the axes below. P is a point on the graph of this relation, A is the point -1, 0, and B is the point x, 0. So as you can see here, we have our relation y equals the square root of 1 minus x squared, that's the semicircle, and the point P is somewhere on this point. It's kind of stuck on there. So I kind of picture that P being able to move around the semicircle. My point A is fixed at -1, 0, and my point B is x, 0. So you got that variable x there, I can change it. And of course, as I change B, my P will change as well. Okay, so what do we need to do? We need to find an expression for the length PB in terms of x only. So what we need to do is find an expression for the length of PB. So this right here, this length right there. Well, that length is simply going to correspond to that length. So whatever this value here is, and that's simply my y value. That's all it is. It's simply the y value there. So the length of PB is simply the height of this triangle, and the height is simply going to be what my y is. But I need to give my answer in terms of x only. Well, that's simply meaning I'm going to say that it's equal to this right here, because I know that my y is equal to the square root of 1 minus x squared, and that's it. There's not much of a big, long-winded explanation for this. As you can see, there's only one line of working here, 1 mark, so no working is required at all for it. You've just got one line where you're going to put your answer, and what you're going to say is that PB is going to be equal to the square root of 1 minus x squared. That's all you need to do. So don't overthink it, go with your gut and you'll be fine. Let's look at the examiner's report here and see how the state fared with this question. So as you can see, 58% of the state got the 1 mark here, and here is our answer, as you can see there. And what they've said is, though mostly well done, some student left their answer as an incorrect and unsimplified form of the distance formula. I don't think it's at all necessary if we use the distance formula. Just don't overthink it. Really make sure when you're doing these types of questions that you don't just kind of jump in, getting the distance formula and making it more complicated than it needs to be. Read the question slowly, really analyze what you're doing, and you're going to be fine. Okay, so let's now just get rid of this and move this over there. Okay, so let's now continue. The next thing that we need to do is find the maximum area of the triangle APB. Well, let's begin by just writing down what the area of the triangle is going to be. So my area is a half times base times height. So a half times my base. So what is the base of this triangle going to be? Well, it's simply going to be this minus that. So it's going to be x minus 1 minus 1 is just going to be plus 1. So it's simply going to be x plus 1, just like that. I want to make sure I don't lose anyone. So if you are confused about how I got that, let me just give you a little bit of an example. If I had 2 points, if I had 5 and I had 2, and I asked you to find the distance between them, you would simply say it's 5 minus 2 is equal to 3. So I just take 1 point and subtract it from another. The fact that I have x here changes nothing. I'm using that exact same principle to arrive at that. Okay, let's get rid of that. And let's now continue. The next thing I need to do now is multiply that by my height, because it's a half times base times height. And we know what my height is going to be. My height is going to be 1 minus x squared, simply the length of PB. Instead of writing it with the square root sign, I'm going to write it as 1 minus x squared, then 1 over 2, like that. Okay, so because it's asking us to find the maximum, we know that this is going to be an optimization question, and therefore what we're going to need to do is find the derivative. I'm going to have to find the derivative of this. So how are we going to do this? All right. We're going to have to use the product rule. We're going to have to use the product rule because we have two things being multiplied by each other. I can just bring this 1/2 to the front and just kind of ignore it for the time being and just focus right here. So as you remember, the way that you use the product rule is you leave the first one the same. I'm just going to leave that there. I'm not going to touch it. Then I'm going to differentiate the second one. So I'm going to first differentiate the inside, which is going to be negative 2x. And then I'm going to bring my power to the front, which is going to be a half. And I'm going to leave what's inside my brackets the same. So 1 minus x squared. And then I subtract my power by 1. So it's going to be negative a half. I then am going to plus onto that the derivative of this one this time. So x plus 1, the derivative of that is just going to be 1. No need to write that. And then it's just going to be multiplied by this, and I'm not going to do anything to that one. So it's going to be 1 minus x squared a half. Perfect. Immediately I can see that this 2 and this 2 are going to be cancelled out with each other. So let's now continue on our merry way. So I'm just keeping this half on the outside here. All right, so what am I going to get here? I've got this x still, so I've got x, negative x, x plus 1. And I'm going to write that as 1 minus x squared, 1 over 2, plus, this is going to be 1 minus x squared, 1 over 2. This is over 1. All right. What I next want to do is I want to make these have the same denominator. In order to do that, I'm going to have to multiply this and this by this right here. So that means what I'm going to end up with is I still have a half here. It's going to be that. All right. What is it going to be? It's going to be negative x plus 1 plus, now all of this is going to be over 1 minus x squared, 1 over 2, and this right here. So what I'm doing here is I'm timesing this. Let me actually write down what I'm doing. I'm timesing this by that, and I'm timesing this by that as well. That's what I'm doing. When I do this one up here, what's going to happen is that my halves are just going to add on to each other. This is one of my power rules. So I'm just going to be left with 1 minus x squared. All right. All right, this is taking some time. So let's keep on going. So let's now just clean this up. dA dx is equal to half, like that. This is going to be negative x squared minus x plus 1 minus x squared over 1 minus x squared half, like that. Now, to find my max, I'm going to find max. What we're going to do is let dA dx be equal to 0, and then solve for x. Solve x. All right, so let's now do that, and I'm going to use the power of technology to make my life easier. So I'm doing this, and what I'm doing is I'm setting dA dx equal to 0. Whoa, my computer just freaked out there for a second. So I'm setting this equal to 0, so I rub that out, and I make that 0. Once I've done that, it's kind of just a matter of rearranging a bit. I could obviously times both sides by a half. I can times both sides by a half, and by doing that, that's going to go away, and I'm just going to be left with 0 still here on the other side. But now what I'm going to be left with is just this. And then once I've done that, what I can next do is I can times both sides by my denominator here, so 1 minus x squared a half, and I'm timesing that on this side as well, 1 minus x squared a half. So that means this will go away with that, and I'm going to be left with, drum roll, 0 is equal to, and just what's on top here. Now if I gather together my x squared, it's going to be negative 2x squared minus x plus 1. I'm now going to have to factorize this, and I don't like factorizing things with a negative out the front, so I'm simply going to change the signs here. So this is like moving everything over to the other side, so just be careful when you do that. And now I need to factorize this. Remember, the way we're going to do this is I'm going to ask, I need two numbers that multiply to 2 times negative 1 is negative 2, so product of negative 2. The sum of 1 And obviously the two numbers that I'm after are going to be 2 and -1 to achieve that end. Then we continue on here, and what we've done by doing this, I hope that you can do this a lot faster, but I just want to make sure I don't lose anyone here. We're going to go 2x minus 1. We then factorize by grouping. We take out 2x, and I'm going to be left with x plus 1. I take out my -1. I'm going to be left with x plus 1. So what I'm going to be left with is x plus 1, 2x minus 1. So therefore, I'm going to end up with x is equal to -1 and 1/2. Okay, so now it's a matter of making sense of this. Let's first look at -1. So if we come back and we look at our graph here for a moment, if x was equal to -1, I'm going to have a height of 0 because it's just going to be there. So that means when we come down here, we could say that when we have x is equal to -1, it's going to be a minimum. Minimum. Because I've just had a, is that how you spell minimum? I've just had a blank moment. Minimum. I think so. That doesn't look right. Maybe it's wrong. And the reason for that is because my area is going to be equal to 0. So that must mean that my x equals 1/2 is going to be my maximum. Yeah, that's correct. I think I'm just going crazy. All right, so what we also need to do, if we come up and we remind ourselves what the question is, we actually have to find this maximum area. So if you remember from the very beginning, we know that this right here is the area of my triangle. So let's come and let's put that there. That's the area of my triangle. So I'm simply going to come here and replace my x's with 1/2. So this is going to be 1/2. And this is going to be 1/2, and this was also squared as well. So what my answer is going to be is 1/2. This is going to be 3/2. This is going to be 1 minus 1/4, 1/2. Let's keep on going. My area is going to be 1/2 times 3/2 times, this is going to be 3/4. Then that is going to be like that, which means my answer is going to be a is equal to 4 times the square root of 3. 2 is going to be equal to 3, the square root of 3 over 8. That right there is going to be the area. Perfect. Let's come now and look at the examiner's report and see how they answered it. Now, I think it's all the way up here. Here we go. Let's bring this all the way down. All the way down so we can have a look at it with our answer. All right. So, as you can see, this question wasn't that well done. Only 15% of the state was able to get to the answer. As you can see, what they did is the same thing as us. They did that. They found that. They ended up with this right here, and then from there, they found the maximum area. Let's now read where the most common mistakes occurred. So the majority of students used calculus to solve this problem. Some students used geometry and trigonometry to obtain a correct solution. Most students managed to find an expression for the area in terms of x. Many of those used calculus found the differentiation of the expression difficult, generally as a result of poor setting out, particularly with lack of brackets or dealing with negative terms. Students are encouraged to practice differentiation involving combination of product and chain rules. So just make sure you're not making any of those mistakes. It was a little bit of a hairy question. I can imagine that being tricky in an exam situation, but hopefully this video has cleared up how you would approach it and you feel comfortable with it. And with that, I'll let you go and I'll see you in the next video.